Now come to the data cleaning part. First, I have imported some library. I have imported pandas numpy for data cleaning process and table manipulation. Also, I have imported matplotlib and c1 for the plotting purpose. As my dataset come in CSV format, so I have used pd.read CSV to read the dataset, and then I use .head. We can see here I have the exact same data that I have described in previous video on Excel spreadsheet. Then I have used .describe method, which return basic statistical information about the dataset. I have passed include is equal to all. The reason for passing this argument because by default the .describe method does not return information about categorical column. It only return about the numerical columns. And if I pass this argument include is equal to all, this all means basically telling this describe method that return all the columns you have. So whether it is numerical or categorical, it will return all the column information. First, brand. This brand column. Here I can see the count is 4345. It means there are total 4345 rows in my dataset. Unique value is 7, means there are total 7 unique brands, like 7 unique brand like brand BMW, Mercedes. These are only 7 in total, and they are all repeated with on 4345 times. Top one is Volkswagen, means Volkswagen is most occurring brand in the dataset. It's occurred 936 times, and other are none because we cannot perform any kind of mean, median, that kind of numerical calculation on the string data. It is not possible. Then price. Price is our target column, and it is also numerical. It unique has none because it is continuous data, so it cannot perform this operation here. The mean price is 19,418. Standard deviation is apart from 25,000, so price is apart or spared around like 26,000. Mean price is 600. So there is a one very cheap car which price is $600, and this price are in dollar, not in rupees, because this is kind of dataset from a foreign dataset. 26 percentile of the price is lie under 6,999 mile, sorry, dollar. 50 percentile dataset are lie under 11,000. 75 percentile is 21, and maximum price is $300,000. So there is a very expensive car which price is $300,000. Then come to the body part. The body type is describing what is the body type of that car. It is sedan or van. So there are total 6 unique body type in the total dataset. Most occurring type is sedan, and it's occurred almost 1,649 times. Then mileage. Mileage is telling us the how much mile that car has already driven, because we are dealing here with used car, not new car. So mean mile is mile it has driven for total car is 161 mile. Standard deviation lie 105. Mean is 0, means there are one car which did not drive a single mile, so we can consider that car as a new car. Also there is a one car, as you can see, max is 980, because that car has driven 980 miles. Also there are other 26 percentile, 7 percentile, and 75 percentile. Engine volume. Engine volume is tell us the engine volume of that particular car. So you can see the mean engine volume is 2.7. Standard deviation lie under 5. Minimum engine volume is 0.6 and maximum is 99. So this, by seeing this information 99 on engine volume, so we can consider this is as a bad data, because no car should have this much engine volume. Then come to the engine type. Engine type is basically telling on which fuel the car has run, if run on petrol, diesel, or other type of gas. So there are total 4 type of gas in our data set. Most occurring in diesel, and it occurs 2019 times. Registration. This column is bold type. It only tells yes or no, because did the car has registration or no. If the car has registration, it will appear as yes, and if the car doesn't have any registration, it will appear as no. So you can see there is only 2, yes or no, unique value. Most occurring type is yes, because most of the car have registration. Yes, and the number is 3947. Almost all the car above 90% car has registration. Year is basically tell the which year the car has manufactured. It is also numerical column. Then come to the model. Model is basically telling the model of the particular car. You can see the unique value is quite large than brand, because it is likely that one particular brand like BMW will manufacture many type of model. So in that case there are only 7 brand, but when I come to the model there are 312 models, total 312 model, unique model in the total data set. Now for the data cleaning on data cleaning, I have decided to drop the model column. The reason for dropping the first attempt, because this data cleaning process I have doing this for linear regression model. So, and I have planned to perform one-hot encoding on the category column. Then I take a look at the model column. Here we have can see 312 unique value. So when I perform the one-hot encoding, this 312 for this model column, there will be another this dataset will come up another 312 features or columns. So in that case, the dimension of the dataset will be very increased. So for that reason, I first attempt I have decided to drop this column. Then I have checking the is null.sum method for checking the is there is any null value present on the dataset or not. I can see that there are in price column and engine volume there are some null value. For this reason, I can see that the count is a little bit different. For this reason, there is some missing value. Now, for dealing with the missing value, there is a rule. If my dataset have 5% or less than 5% value are missing, then we can safely remove those rows. So here I calculate, I take the greater number 172 and I divide it with total unique rows, and I get the result 0.03, which is 3%. That means 3% of total data has missing value. So I can safely remove those all row. So I have just used drop now method. Axis is equal to 0 means drop, it will drop all the row when you find any missing value on this price column and engine column. It will drop all the information for that particular column. And I have passed in place is equal to true, so the dropping method take on the original data set. Now I have plot a distribution on the price column. I can see the most of the price are lie under the 50,000 rupees, but as I see here, the one is an expensive car which has $300,000. So this is right skew. We have come to the all 3,000 rupees from the 50,000 rupees. So we have to take care of it on data cleaning process. So for that purpose, for that reason, as my data have outlier, so I have choose to use quantile method. So what this quantile method will do, I have decided to create another notebook. Here I am seeing, here I will show what is the quantile method will return. Here I have a simple dataset, super simple dataset. That the value is nothing but 0 to 100, 0, 1 to up to 100. So I have first decided to take 50 quantile. This quantile method return on a single integer, the quantile value. I have imported numpy and I use np.quantile. This np.quantile and pd.quantile, what I have used on my dataset, are exact same. Here, these are exact same. These all return a single integer. I have first decided to take 50 percentile. I have passed in use np.quantile and pass the dataset, which is this, and pass the fraction of the number. This means this 0.5 means I want 50 percentile. So it returns me 50. It is returned because 50, the dataset is very simple. It's lie 0 to 100. The 15 percentile value are lie and under what is 50? This 50. So this is my 50 percentile of the total dataset. As 90 percentile is 90, 10 percentile 10, and 99 percentile is 99. Means 99. When I take 99 percentile, because I have in the dataset I have used this function, this method, I use 99 percentile of the dataset, so it returns this me all the 99.0 means 99 percentile value are returned. until this range. It will remove the highest value or the last value. So here I also take the neighbor 99. It returned me this value, 129,812. This value. This is the large value. Now I have as this queue is a only single integer, so I have filtered the price column. I have taken the telling this by this line I have telling that return me the data frame where the price column is less than this much value, where this much value is nothing but this value. So I can see that I have by the describe method I have see that the max is max is reduced. Now initially the max price was $300,000, but now the max value is decreases. So I have successfully cleaned the data only for the price column. Now I have plot the other. Here I have plot another plot. This one is first after out removing outlier and was first and it was the initial graph. So you can see there is a very slightly long right tail was there in the dataset initially, but after that it is also have some outlier, but it's quite normal. So we can use this other than this one. Then I have created another plot for other three numerical column, which is mileage, engine volume, and year. So I can see the dataset has quite normal, but engine volume are lie between 0 to most of the engine value are lie very near under 10, but it's come to the 99 or 100. As I can see from the describe method, engine volume come to the 99.9, almost 100. So I have used the same quantile method. I have taken the on the mileage column. I have taken the 99 percentile and I pass the argument that return me the data frame where this mileage column value have less than this much value. So I can see that after removing the outlier, the data is looking quite normally distributed. Now engine volume, I have used the same thing on the engine volume. Initially it was up to 100, but after the removing here it is I have not used any quantile method because I have to search on the Google the what is the maximum displacement or the engine volume can be. I don't need to search because I was a mechanical engineer, so for that I use 6.5. I know the maximum volume can be 6.5 for the highest any sports car or any economic car. So return me the also I have this line telling me return me the only engine volume which the engine volume has only less than 6.5. I can see the after removing the outlier the data set is looking quite normal. Now year of the car. So here we can see the most of the car are quite new, like most of the car have like after 2000, but there are also some vintage car which lies are like some cars are before 1970. Also some cars are lie on the 1980 or 1990. Here I also use the quantile method. Here I have used 0.1 because first initially I was dealing with the right skewed data. That's why I take the 99%. That's why I take the 99% of data and return me the all the value which is in the left side. But in the case of year, I want to take the last value, means the newer car. I have to eliminate the older car here. So that's why I have here instead of less than I have passed the greater than. So this 0.11 will only return this much only this side value, not left side value, and then I have used greater than, so it will return me all these value which are above this older car. So you can see I have initially it was up to 1960. I don't know it's after before 1970, but I can see now I am starting with 1985. So it's eliminate this left side data. Here you can see the on the graph. Now I have used now after the cleaning some process I have checked the data frame what I have now. Here I have eliminating some rows. Now I have end up with only 3867 rows and total 8 columns are there. Now I have used the reset index because the index was a little bit messy. Then I have used describe all. Then I finally check the describe method on the cleaning dataset. Here I can see the unique value are still 7, but the price is also price. The mean price is becoming different, and now next price is this one. And engine time volume, as I clean the engine volume now in the max engine volume is 6.3, so it makes sense. Now I have used that how many uh, rows I have removed. So that's why I use this one. It will give me the return shape. Return shape 0 means you return on the number of rows. I have written 158 means I have removed the 158 columns. But it is not the same. Initially I have removed the 170 missing value. Total 330 column I have total removed, because this one I removed on in the first beginning before starting the data cleaning process. After that I save the data set.